Awesome, seniors. Welcome back from spring break. The first lecture, we're going to be talking about even and odd trigonometric functions. So I'll give you a second to go ahead and put that title down. But before we jump into what an even and odd trigonometric function is, I think it'd be really valuable to take a step back and talk about what an even and odd function are. Now, even and odd functions make your life easier. That's why we're looking at them. They allow you to take shortcuts if you can recognize an even and odd function, because it basically takes whatever workload you have with an even and odd function and it cuts it in half, because you can use symmetry. Once again, symmetry, same thing, sort of looking back and forth across xy axis. So a function is even. A function is even if it adheres to this. And I remember this because it was on our first semester final exam. So f of negative t is equal to f of t. Now, if you can't exactly understand what that means, I can give you examples, and I can also sort of draw it out. And I'll do that with both even and odd functions. So say, for example, f of x is equal to x squared. Now, I'm going to sort of break the suspense here and just tell you that x squared is an even function, okay? And one way to test that is to say, okay, if I take any number for x, if I plug in the positive value of that and I plug in the negative value, they should be exactly equal. So say I take 1 and negative 1. Those are always great ones to start off at. So if I say f of 1, this is just going to be equal to 1 squared, which is going to be equal to 1. If I plug in negative 1, I'm going to get negative 1 squared. Negative 1 times negative 1 is also just going to be equal to 1. So these two things are equal. This tells me that it's an even function. Awesome. Now, even functions, you can also visually see what they look like if you plot them out. Now, x squared, we're talking about a parabola. It's a second degree polynomial. And so it starts at the origin and it just kind of goes up like this. Oops, got a little bit excited there. So x, y, and what an even function means is it's symmetrical about this y-axis. So if there's a value over here at positive x, then it's going to have that same value here at negative x. And so, for example, if I did that with 1 and negative 1, say I went over here at 1, and my y value would be equal to 1. That's what we calculated right here. If I went over to negative 1, my y value should be equal to negative 1. And I drew it a little bit funky, but if you plot it truly, if you're a better artist than I, then sure enough, f of negative 1, when x is negative 1, it's going to be equal to 1. That's what we calculated right here. So it's symmetrical about the y-axis. Now, odd functions, once again, just to review real quick, are a little bit different. Now, it's going to look very similar how the definition goes, but there's one subtle difference here, okay? And that's this negative sign right here. So up here we've got f of negative t is equal to f of t. Here we've got f of negative t is equal to negative f of t. Now, what in the world does this look like? Okay, so let me give you a function here. So say f of x is going to be equal to x cubed. Once again, I'm going to break the suspense here and tell you that x cubed is, in fact, an odd function. And once again, how I can determine that is I can plug in values and figure it out. And I should also notice that this even function, this isn't unique to 1 and negative 1. You can do it with 5 and negative 5, 3 and negative 3. The same thing with odd functions here. So, for example, instead of 1 and negative 1, say I did 2 and negative 2. So f of 2, I get 2 cubed. 2 cubed is just equal to 8. Okay? Now I've got f of negative 2. If I plug in the negative value, then I get negative 2 cubed. Now, negative times a negative times a negative is going to be of a negative value. Okay? And then 2 times 2 times 2 is going to be equal to 8. So this is going to be negative 8 right here. So I've got f of 2 is equal to 8, and f of negative 2 is equal to negative 8. So these are negatives of one another, right? Same absolute value, but one is the opposite. One's going to be a negative of the other. This tells me that they're going to be odd, and that's exactly what this definition says. Now, if I want to sketch this out similarly, I'm going to have to draw my coordinates a little bit differently, because there's definitely symmetry that goes on here. Once again, this beautiful symmetry that pops up all the time in math. However, it's not symmetrical about a particular axis, but it's sort of symmetrical about the origin. So x cubed, for example, kind of looks like this. It comes down, hits the origin, and then goes back down like this. So if I have, for example, 2, if I go over 2, then I'm going to go up 8. Say that puts me right about there, right? So I'm in the positive, I'm in this quadrant right here. If I go negative 2, say I drew it a little bit weird again, but then I would go negative 8, that would put me exactly down here. So whatever these points are, if it's positive, positive, I'm going to have that exact same point, but it's going to be in this fourth quadrant, and it's going to be negative, negative. Now, how does this relate to trig functions? Well, trig functions have a lot of symmetry. And they have a lot of symmetry because they're related to the unit circle. Right? The circle, it just goes around. Circles have a lot of symmetry, right? So when you're talking about sines and cosines, they're going to have symmetry as well. Okay? So, and if you even look at the unit circle, you can figure that out. Okay? So our goal today, our objective, after we've reviewed what even and odd functions are, is we want to use even and odd functions. Not just even and odd functions, but even and odd trig functions. Trig functions. Okay, so now what we'll notice if you take a look at the unit circle is there is this symmetry. And what we see is that the cosine of a negative number, or negative t, is exactly equal to the cosine of t. Now if we go back up to our definitions of even and odd functions, looking at even and odd, if I've got f of negative t is equal to f of t, this tells me that this function is even. So I've got an even function. And also, I know it's symmetrical about the y-axis. Okay, so cosine is an even function. Now if I look at my sine functions and my sine values, those y values on the unit circle, what I'll see is that the sine of negative t is equal to the negative sine of t. And once again, if I jump up here and I look at my definition of my odd function, that's exactly it. F of negative t is equal to negative f of t. That's exactly what I've got here. So this tells me that the sine is an odd function. And it's symmetrical about that origin. Now, if I want to plot these out, and I'm going to try to draw it out, but I've also got a handout here that sort of is going to guide us through it, or is going to illustrate it a little bit better. So here we've got the cosine function. Let's start there. It's the even one. It's a little bit easier to conceptualize. Here I've got my y-axis. This is going to be my origin right here, and my x-axis. Now my cosine function, I can see it exactly mirrors itself over here, versus if I flip over here and do this, my function mirrors itself around the y-axis, right? So if I've got a value, say, right here, I'm going to have that exact same value at the negative point. Or if I've got this value right here, I'm going to have this negative value right here. Same thing all the way down. Cosines and sines, they just continuously repeat each other. So the cosine is an even function. Okay, so in your notes, I'm going to try drawing this out, and I want you guys to have this as well. So x, we're going to go y, and let's see, so the cosine, since we're talking about the unit circle and we're dealing with radians, so I need pi over 2, this is going to be pi, and these are just values of what x is. This is going to be 1.57, this is 3.14, 3 pi over 2, these are just sort of my landmarks for when I'm trying to draw this thing out. Same thing on the negative side, so I've got negative pi over 2, etc., etc. Now the cosine is going to hit up here at some particular point, and then it's going to drop down and it's going to hit the x-axis at pi over 2. And it's going to bottom out at pi right here. And it's going to come back up and hit 3 pi over 2. And it's going to go through there and come back up. And it does the same thing in this manner. So it bottoms out at negative pi and then comes back up. Okay, so this is my cosine. Cosine of x. And you can quickly see why I have a printout of this based off of my artistic abilities. Now if I look at the sine of x, the sine of x is the one I've got in green here. Now it's an odd function. It's going to be symmetrical, but sort of about this origin. So if I have a positive value, say like right there, and I come over here, I've got a negative value, That's going to be right there, right? So first quadrant, fourth quadrant. So if I go in the positive x direction, say I pick a point right there, so I'm going to go positive x this direction and up this much. I'm going to go negative x this direction and down this much, right? So instead of right and up, I'm going left and down. So it's symmetrical, but it's more symmetrical about the origin. Now I'm going to try to sketch this out as well. Now the sine function crosses the origin right there, and it tops out at pi over 2, and then it'll cross at pi. So it's sort of, let me sort of put a dotted line there so I don't mess this up. So it goes up to there, and then it comes down, crosses at pi, and then bottoms out again at 3 pi over 2. And same thing here. So it tops out there, crosses, bottoms out, and then goes back down. Okay, so this is going to be my sine of x. And because I'm shameful, I'm going to go ahead and put this one back up so that you guys can try to copy from there. If you need to pause the video here, go ahead. Hopefully it should be clear enough so that you guys can see it. Now, even in odd trig functions, they basically just make your life easier. And how does it do that? Okay, so say I know what the sine of 30 degrees is, okay, or pi over 6. So if I know what the sine of 30 degrees is, sine of 30 is equal to 1/2. Well, that tells me that the sine of negative 30 degrees, because I know that sine is one of those odd functions, sine of negative 30 degrees is going to be negative 1/2, because it's like goes that first quadrant, fourth quadrant relationship. So positive, positive, this is going to be negative, negative. Say I did the cosine of 30 degrees. So I know the cosine of 30 degrees is going to be equal to square root of 3 over 2. Well, now I know that the cosine of negative 30 degrees, because cosine is an even function, this is just going to be equal to the negative, or sorry, it's also going to be equal to square root of 3 over 2 because it's an even function. So positive, positive. And sure enough, if we go back, so 30 degrees is about pi over 6. So if I go pi over 6 over here, sure enough, I'm going to get square root of 3 over 2, which is about 0.866. If I go negative pi over 6, and I'm going to go up, I'm going to also get a positive 0.866. Now the sine, if I go sine of 30 degrees, now I'm looking at the green one. So sine of 30 degrees, I get a positive 1/2, which is going to give me right there. If I go the negative sine of 30 degrees, I'm going to get a negative 1/2 right there. All right, so I'm getting that even-odd relationship. All right, I'm going to leave it there, guys. We're going to pick this up in class tomorrow and go from there. See you then.